Hello and welcome to this session where we're going to explore how to create a pipeline of video generation. All these people here, they have something in common. None of them really exist. All of them were created with artificial intelligence. In this particular case, with a Stable Diffusion 3, a model of text to image. And all these people here have been animated from the still images with the DreamTalk image to video technology. So let's find out how we can accomplish that. Join me. DreamTalk is the system created by researchers from Tsinghua University, Alibaba Group, and Huazhong University of Science and Technology, which enables to create videos of people talking directly from the audio sample and a still image. All the lip syncing and all the expressive face movement is created by their AI system. If you want to know more about how it operates under the hood and some preliminary examples, please watch the first video in this series on DreamTalk. Today we're going to be focusing on scaling up our video generation pipeline, and for that we will be creating multiple portraits with text to image. For that we are going to use a Stable Diffusion 3, a text to image model from Stability AI, which will allow us to create multiple faces. We are going to need some audio samples to go with the generated images, and although we could create those with artificial intelligence, in this particular case we're going to go with this fantastic data set called Common Voice 17 from the Mozilla Foundation. It contains more than 20,000 hours of spoken voice in over 100 languages. We're going to take just a small sample of English recordings, both from men and women, so that we can match those recordings to the generated faces. We are now in our familiar Jupyter Notebook setup running in VS Code. This is connected to the VM in the Hyperstack platform. If you need a refresher on how to set up an SSH connection or how to connect your VS Code to the VM in Hyperstack, feel free to check out the videos available in our channel. Now we're going to get started and load the data set from Hugging Face. Important to notice that we are setting up streaming to true. This means that we're going to be fetching each audio sample one by one. This is important because it's a huge data set, as you just saw before, and we don't want to download it all. We just need a few samples. Next, we're going to define a helper function to help us retrieve the audio samples from the dataset. And let's examine one of them. This is now being fetched from the Hugging Face Hub. And here it is.
We are going to the football game tonight.
So there you saw. It's an English voice speaking a normal sentence. We're going to get a bunch of those to animate the still images and get talking heads. All right, let's go ahead and write that to file, which we will need later. And now we're going to use the Stable Diffusion 3 model to generate faces. So here's the prompt. It's going to be either a man or woman, depending on the gender of the audio that we fetched. It's going to be just looking at the camera, casually dressed, flat background, uniform lighting. Simple prompt, 28 inference steps, and 1024 by 1024 resolution. This is now running on our GPU. There. Okay, let's see what was generated. And here's a picture of a man. It didn't follow completely all the instructions that we gave it, but this is normal in these kinds of models that sometimes are hard to guide. Like for instance, it didn't have a uniform background or a flat background, but it is looking straight at the camera, and it is a man, which is what we ask for. So let's write down to file. There. And now we can proceed to the next step, which is creating an animation from that image that we just created and the audio sample that we fetched from the dataset. So we can use our generate function, which we explored in our previous video. And the video was generated. So let me fetch it for you. This is going to be in output, sample mail.
We are going to the football game tonight.
So there you go. We could successfully create a face from a text prompt, associate it with a sample voice, and create an animation of this man saying that phrase, even though this man doesn't really exist. That's pretty interesting, right? So let's scale this up and run it for 100 generations. So I'm going to leave the Jupyter Notebook set up, and I'm going to go now to the terminal. We're now in the terminal, and we're going to run this script, batch generation in assets mode, to generate the still images and fetch the audio files. This is going to fetch now a larger piece of the data set. Let's go quickly to the code to see what that looks like. And here we are fetching from the Common Voice dataset, but since we're performing some filtering for male and female voices, then we're downloading the test split for the English language, and we're going to be using these filters for the generation. Our assets are now generated, both the audio samples written to file and the synthetic images, and now we can proceed to generate the videos from them. Remember to change the virtual environment so that you are in the correct environment. The generation is now complete. It took about 10 minutes, which averages to about 10 videos per minute. Consider that not all the audio samples have the same length, but in average, that's what we get. In terms of the asset generation, we got about 14 pairs of audio file and image per minute. Okay, let's see the results of those generations. Here on the left are the images created with Stable Diffusion 3. So let's do some preview. And we've got different images of men and women that we can use for the animation. If you notice, there'll be some oddities. Whoa, this is interesting. A fish or something. We will see things like these awkward hands, the uncanny valley experiences that are well known of these diffusion models. Like again, the hands here are not correct, but the faces for the most part are very good. And the technique is going to be able to pick just the face from the image and animate that section. So I have already handpicked a few of them to show you. Let's go over them.
A streak of color ran down the left edge.
There you go, that's one. Let's take this other one.
They said that they were thoughtfully vaccinated.
Okay, so that's number 77. That's interesting. Let's fetch number 77 over here. So this is the original image. And you saw that she had this kind of sneer.
They said that they were thoughtfully vaccinated.
Looking into our code, then if we go to the generation function, we can see that we can choose from a range of moods: angry, contempt, disgusted, happy, and so on. So even though the recordings are neutral, the sound recordings are neutral, we're spicing the generation up a bit by giving a random emotion. And here you saw that she had a bit of a sneer, which corresponds to the reference video here. You see, this is the reference video that was given by the authors and which is used to inform the frame generation, and that's why we can see that that is near in her face. So let's continue looking at some of the other generations that I have handpicked for you.
These names may stem from High German and come from Eschwigi's original Germanic name,
Which was pretty good in the lip syncing and head movement.
The legislation was a failure for a number of reasons.
Okay.
I assume this was your doing.
And this is again a bit of that snare reference, possibly.
Gomer was forced to abandon Carthage, period.
Okay. Very good lip syncing in there as well.
Her husband joined with her in establishing a law firm together.
And one last one.
The department includes the orchestra, choir, band, visual arts, and theater productions.
And those are some of the best clips that I have chosen to show you. And I would like to also show a couple of the not so great ones to have a better overview of the capabilities of the technique.
So how would we the next book go?
So in this one, the rendering around the mouth wasn't very precise, and also in the contours of the head was kind of blurry. Let's check what was the original image that was used as the source, which was, good enough and clear. Let me show you one more, which isn't that accurate. This one.
For example, saves the current file, goes to the search menu.
So here the mouth seems slightly off in the face. Also the audio wasn't very clear, maybe that also contributes to it. But let's check the reference image, which is this one. And again, the face, was very clear. In this second and last session dedicated to DreamTalk, the technology to create video animations of talking heads with AI, we have seen how to scale up a video generation pipeline. We have started with synthetic images created with text to image with the Stable Diffusion 3, and then we have collected audio samples from an open source dataset to create the final animations. You can easily see how this could be helpful for creating compelling user experiences that feel very near to your end customers. I hope this was interesting to you. Thanks for watching. Until next time, stay safe.